asymptote. This one will, which one had, okay, vertical asymptotes, horizontal asymptotes.
We didn't figure out why yet, though.
Oh yeah, we're getting there. Okay, oh I meant to write that in black, but anyway. So this one has an oblique asymptote, that's a diagonal asymptote. How do we find that? We find it by dividing. Yeah. Okay. Let's return back to this one. We want to find the vertical and horizontal asymptotes. Okay, how do we do that? Remember, vertical asymptotes will be x equals and y equals. Yes, so what we figured out is to find the vertical asymptotes, any function, it's all about the denominator. Let the denominator equal 0. So we would let this denominator equal 0 and solve. So it's a factorizing x, 4, 1 minus plus, I think. So x is minus 1 and x is 4. So there's our two. Okay. Was there a horizontal asymptote?
Is it just -6
For which?
No, there was equals.
No.
This is
No, that'll just be a point. Yeah, that'll just be a point. I'm looking for the asymptotes, not the axis intercepts.
There's no.
There's no horizontal in one of them. There is a horizontal on this type, yes. And this type will always be y is equal to 0. And we discussed this yesterday, that it does cross that point, but asymptotes are, as it tends towards infinity, as x goes either directions towards infinity, what's it going towards? And it's definitely it's approaching that y is equal to 0. Why is that the case? Well, because as x gets bigger and bigger and bigger, this denominator is taken over. We're going to get, this will not be able to keep up with this, if you think about that. So this denominator is going to get huge as it approaches, as x gets bigger and bigger. So you're just getting a really tiny fraction, aren't you? You're going to get 1 over a million and whatever, 2 over a billion and so on. So eventually this denominator is pretty close to 0. And the same thing will happen if it's negative. It'll get closer and closer to 0 from the other side. Okay, we'll talk about that a little bit more as we discuss the behavior of the function. But that's the vertical and horizontal asymptotes of this style. This one will not have a horizontal asymptote because this is going to win.
I don't get why when finding vertical asymptotes, why do you let y equal 0?
No, you don't. For this, dividing by 0 is not allowed. So you won't get an answer.
No, but letting y equal 0.
I don't, here?
No, just for like any other.
I didn't let y equal to 0 here.
No, but yesterday you said when finding vertical asymptotes,
Let the denominator.
That's the y-intercept.
That's the y-intercept, yeah. So the denominator equals 0 for the asymptote. Y equals 0 to find the x-intercept, yeah. Okay, so this one does not have, so there's no horizontal asymptote. But there is a vertical asymptote where x is -2. So once again, the vertical asymptote, let the denominator equal 0. So x plus 2 is equal to 0, so x is equal to -2. So that's our vertical asymptote here. Oh, x equals -2. X equals -2. So that's, as soon as you're approaching vertical asymptotes, let the denominators equal 0. And then we have...
Wait, is there like a general way to find a horizontal asymptote? You know, how
y is equal to 0 here. Why is it always y is equal to 0? In this case? Yeah, and for these ones. It's always this case because no matter what quadratic you have, so it's in this particular form. It's a linear divided by a quadratic. The quadratic's always going to win. The x value of the quadratic is always going to get huge before this one can keep up because you're squaring the x. Therefore, this denominator, as we get bigger and bigger, is always going to get bigger and bigger faster than this, which means this is going to turn into a very small fraction. So small, in fact, it's going towards 0. So imagine as we start to sub in numbers, when you start to sub in like...
We just assume.
Well, we can assume it because if I sub in 1 million for x, this is going to be 2 million. This is going to be a million times a million before you even start off with. The denominator is going to be to that degree bigger. And when we have a fraction with a really large denominator, okay, even if the numerator is big, the denominator would be exponentially bigger. So this is going to be a tiny fraction, because all these zeros will cancel out with some of these, and we're just left with this. Now, it mightn't be 1 here, it might be 2 or whatever. But this number is tiny. Convert that to a decimal, and you're talking about, and we're talking about going to infinity. So as it goes to infinity, this number is going to get even smaller. But will it reach 0? No. So that's the concept of the asymptote. It's not going to reach 0, but you pretty much think it is, because this decimal is going to get so small. Yes?
How does it make sense that it does cross 0 at one point?
Well, it does cross 0 at one point because we see that early on in its life, yeah, well, early on when we're looking at the function, we can get a value for when, well, what is 0? When y is 0 and when x is 0, we can get values for those things. We can get where, so when y is 0, we let this equal to 0, multiply this over, we get 0, and you get 2x minus 6 is equal to 0, so x is 3. So it does cross it at some stage, but as it goes towards infinity in both directions, it's just getting close to 0. That's what an asymptote is. It's a loud cross, but we're talking about it going to infinity.
But without a graph, you wouldn't really realize that like 0 would be an asymptote.
Yes, you would, because you just look at this and you think about, well, these are the only, well, there's a few types. These two, and then the other one, which we dealt with earlier on, the ax plus b over cx plus d. Now you see for this one that the asymptote mightn't be at 0 because these will keep pace with each other. Like there's no, whereas this one, clearly the denominator is going to be winning, like it's going to be dominating when it goes to infinity. You're squaring versus you're just multiplying. So therefore it has to have an asymptote somewhere. What's it going towards? It's going towards, it'll always go towards 0, this one.
I feel like that would be really confusing to find that out for the first time.
Well, yeah, okay, but now you know. So this type will always have a horizontal asymptote.
We're never doing this with 3 dimensions, right?
No. So this type has a vertical asymptote when we let it equal to 0. Wouldn't have a horizontal asymptote because it's going to tend towards infinity in all directions. But it does have an oblique one, which is about that dividing. We talked about that a little bit yesterday. So when we divide x plus 2 into this.
I don't know why you divide it. Why does that work?
Okay. Why does it work? Anybody? Alex.
We did it last time, you got it.
No,
we
but
only
it's
said
saying why.
Yeah, why is it? No, we just did it.
Yeah, because you're trying to
You didn't
solve
know.
for when y equals something.
Mm-hmm. Yeah, so we're trying to figure out, so we get the thing over here. When we get the asymptote here, it's, let's say we have 2x plus 3 over, let's pick 7x minus 6. We let the asymptote, we know the asymptote is 2 over 7, because it's the thing that makes the left-hand side equal the right-hand side. Now, so when we let y be 2 over 7, what happens? We get 2 over 7x plus 3 minus 6. Okay, and we cross multiply, then we get 14x minus 12 is equal to, what's that, 14x. So this 14x is the key here, plus 21. So these will cancel, and then we're left with this, that's not equal, okay? Doesn't? No, it does. Okay. So we're trying to create something similar here, but it's not as obvious as just divide one by the other. So we're kind of forcing the division here, 2 over 7. We're doing something similar here to figure out what value is the point where it makes this nonsense kind of answer.
How do you know if it has a vertical asymptote without graphing?
How do we know if it's vertical?
Oblique.
All of these will have some sort of oblique one.
Every single function.
This form. These are very specific forms. So we're only talking about a linear divided by a quadratic and a quadratic divided by a linear. And then we're not talking about cubics divided by quadratics or anything like that. We're just talking about these types in this course.
What if it divides linearly? What if it divides without
Well, it'll be a different type of function then, because if it divides evenly in, wouldn't it be just be a normal rational function? Yeah, it'd be a normal rational function, yeah. So it'll either be, or if it's the other way around, it'll be a rational, and this would be a linear. Yeah, it'll just be a line. Okay, so to find that, we did this yesterday, so that's why I'm doing this quite fast. 2x squared plus 4x, I think, minus to subtract. Minus x, I'll slow down in case I make a mistake, minus 9. We have to do minus 1, wasn't it? Minus 1 times minus x minus 2. Change the signs again, and x is minus 7. So we can rewrite this function then as, this can be rewritten, y is 2x minus 1. So this fits into that once, or this that many times, but we have a remainder minus 7 over x plus 2. All right, and the oblique asymptote is this. Y is equal to, when y does equal that, we have this equals this, so we're just left with this bit, which whatever value for x puts in, it won't make sense. Right.
So linear over quadratic always doesn't give you an asymptote.
Linear over quadratic will give you normal vertical and normal horizontal. Horizontal will always be 0.
Yeah, and never.
No obliques. This one will have one oblique and one horizontal. Okay, and that's the bit you need to remember, I think. Now, what we didn't get to yesterday, we got to that far, is how to draw a sign diagram. So I'm going through this quite fast.
Oh, we did that. That was just the flat.
So a sign diagram is the x, we're looking at the x-axis. So you just draw a sketch. This is the x-axis. What bits of information can we put on this?
Origin.
You don't need to put the origin on. Okay, stop. These are rhetorical. We put the intercepts. So we need the intercepts. What's the x-intercepts and the y-intercepts of these functions to draw a sign diagram? So where does it cross the x-axis, what I'm asking? Sorry, this asks for the y-intercept. We don't need it for the sign. Only the x-intercepts are on the... So how do we get... It's an... Yeah, it's a quick graph. How helpful it is if you can draw the full graph, not very. But if you don't have time to draw the full graph, sometimes it can be useful to look at where it is above and below the x-axis. Well, let's see. Well, let's have a look at one, and then we'll see does it help us with anything. We haven't done anything yet. We need the x-intercepts because this is the x-axis. We want to know where it crosses the x-axis. How do we get the x-intercepts?
3.
Yes. So we let y is equal to 0. Bring this over here. That's 0. Solve it. X is 3. Everybody okay with that? Do I need to do? So when let y equal 0, and we get x is equal to 3.
Wait, what? No, I need explanation.
Okay, so to find any x or y intercepts, you let the opposite equal 0. So to find the x-intercept, we know that the y value would be 0. So I let this y be 0. So I multiply. So if you want 0 is equal to 2x minus 6 over x squared minus 3x minus 4. Multiply that up there. Comes 0. 0 is equal to 2x minus 6. Move the 6 over. X is 3. Okay, so we have x is 3. Let's put that over here. 3. Generally, they don't have it. They have it like this. Weirdly. Okay. That's the only place it crosses. That's not enough information. We also have vertical asymptotes.
Why is it so far?
Why is it so far over there?
Is this from left to right or right to from?
Well, I'm taking that as 0. You can have it.
Oh.
If you're not, I'll put 3 here. That's better.
Yeah.
Okay.
Is it not handy to just draw 0?
You could, yeah. 4 I'm going to put here. Why did I put it as a dotted line? That's an asymptote, yeah. Minus 1 is a dotted line also, down here.
Is that
Okay.
really what I just said?
Oh, sine has a lot like sine.
Yeah.
Yeah, not sine cos tan. No, not sine cos tan. Sine, as in sine. Okay. That's all the information that I have regarding x. All the rest of the information is regarding y. So what do I put in these spaces?
Should we draw the graph?
Okay, so if we had, and I'll just do a quadratic because we're used to them. If we had the two intercepts here are 1 and 3, we'd draw 1, 3, we'd put minus, plus, plus.
Oh, it goes under, yeah.
So the y values between 1 and 3 are all negative. They're all negative. You brought them over. They're all negative values, yeah? Where the y values either side of 1 and 3 are all positive y values. So these signs, and this is where the sign comes from, is the y values. The y value is positive or negative. Is it above or below the x-axis between these two numbers?
Why can't we just show that? Why can't we just go under that x-axis?
You could just draw it, yes, of course, yeah.
Yeah.
Okay, but how would we show it without having to, how would I figure out is it above or below? Because this looks quite complicated. And if you drew it,
We already know what the assumption is.
Down and up.
okay. Where is it plus and where is it minus?
Would it be minus in front of the x, the minus 1, and then plus after the 3?
It'd be minus before the 3 and then plus after.
All right, I think this one will be the easiest one to find. Why do I think this?
Because it's less than a
There's a certain value between minus 1 and 3 that's really easy to test. 0. So if I test x being 0 into this, I'll get a value. What value do I get?
negative 6 over 4.
Negative 6 over negative 4, which is positive, isn't it? That means all that bit is positive. So if I test any point, it'll all be the same. There's no reason, it hasn't changed, because this is where it crosses the x-axis, this is an asymptote, so between those two, it can't change sign. Otherwise, it would have to cross the x-axis again. Yeah? Do you get this? So if I test a point between 1 and 3 here, it has to stand for all of these points. Why? Because if it didn't, it would cross back over somehow between them, and there would be another intercept.
Yeah.
So therefore, if I find one point does one thing between these two values, all the points does that. It is all on the positive side. The graph is all on the positive side. What about here?
So we're drawing, it never reaches negative 1 on the x-axis.
No, it's never gonna hit negative 1 on the x-axis. No.
Jeez, remember the ones that go like down and then it comes up?
Yeah, so it might be like, it might have some weird shape where a bunch of different places where it's above and below.
Before negative 1 is negative.
It's still in between the two roots, right? Wait, where's the other root?
There's only one cross. This one only crosses the x-axis at one point. So we're dealing with.
Wait,
But we know the actual x-axis itself is an asymptote, so it doesn't. You know it's not going to cross it again. It only crosses at that one point, but it will tend towards it. So the question is the function above the x-axis before minus 1, or is it below? So it either goes like this or like this before minus 1. Which one is it?
the down one.
If the right one is plus, then the left one should be below.
You'd imagine it should logically, but we've seen functions that do this.
Yeah.
Yeah.
Oh,
Maybe you haven't seen it, but I think we drew one yesterday that had that.
Yeah, we did.
Yeah.
The one where it's boom, boom.
Okay, so is it positive or negative? How can we test it if we're not sure?
But the x value.
Just put in an x value. Negative 2, if you're unsure, just put in an x value. Do it really quick. We know negative 2 sits there. Negative 2, that's minus 6. Negative 2 here. Squared minus 3 times negative 2 minus 4. That's negative 10 on top here. Yep. That's squared, in case you're wondering what that is. That's 4 minus, that's 4, oh, is 4,
Negative 10 over 6.
4 plus 6 minus 4. Is that a positive or a negative number when I work it out?
Negative.
That's a negative number, because this denominator is going to be positive, isn't it?
Yes.
So that's negative.
I was right.
Yes, it is negative. What about between 3 and 4? Test.
Also did. Oh, negative. Between 3 and 4 negative, because it has to cross and go down, right? Because it crosses the x-axis. Oh, it could be could be a repeated root, but I don't think it is. I think it goes down.
This one we know it crossed the x-axis here, didn't we? Do. This is an intercept.
Oh yeah, it's not.
That's an intercept. It's not an asymptote. So we know it's crossed. So it must have been the other one after that and before that.
Yeah, negative, and then positive again.
No, on the other side.
Hmm?
Past the line.
No,
Is it Josh?
I think it's positive again.
No, you wrote it.
Is this the wrong place?
No, because
Yeah.
there's nothing.
No,
Josh,
Minus is on the right.
there's nothing past the other line. There's nothing past the voice.
Josh.
There it is.
Oh no, I mean yeah, but like, let's see.
Oh, minus here? No, minus. This is the crossing point.
Yeah.
This is the only intercept I know. This is the only.
Oh.
Yeah. Yeah, okay.
My bad.
All right, 4 then.
Plus.
Wait, is that it? Are we not drawing a line on there? I don't like it without a line.
Yeah. To be honest, I don't really like sign diagrams either. It's way better. They're slow and they're generally not asked for you to do. Some people find them useful just to visualize. I way prefer to just use your calculator and then just draw it. But after this one example, we should know how to do it. You just test a bunch of points between your asymptotes and your x-intercepts.
Wait,
Anyway.
a graph can be a graph without any line?
So this is a graph without a line, yeah. This is a sine diagram. Sine refers to what the y's are doing. So we know it's above, below, below. What's it after 4?
Above, plus.
You sure?
Yes.
Yeah, it is.
Less.
No, it should be
This,
After
you
4?
sub it in, put 5 in.
Yeah.
Yeah.
So if you're unsure, just put a number
It
in.
becomes 4 over
6,
I don't
Yeah.
see
4 over 6.
So once this becomes positive, this will, like, as this gets bigger, it's always be positive because this is squared. Like once this hits past positive, we're talking,
I don't get how it gets past 4 because I thought 4 was an asymptote.
Because there's another line on the other side of the asymptote.
Remember the funny graphs?
Oh, but the sign diagram.
okay, so that,
So the sign diagrams only work if the horizontal asymptote is y to 0.
no, it'll work, whatever. So we just drew a sine diagram for a quadratic. It just says what the y values are doing between the bits we know on the x-axis. Just gives you an idea.